Good afternoon, class. So today, I am going to teach you the concept of complex numbers and what are the important things that you need to know about complex numbers. So, let's start our lesson. So first is let us have the learning objectives. So, at the end of the lesson, you should be able to understand the concept of complex numbers and abstract algebra, identify and write the complex conjugate of a complex number, prove the different properties of complex numbers and apply these properties. So, ayan po yung ating learning objectives in our lesson. So, first is what is complex numbers. So, kapag sinabi po natin complex numbers, it is a backbone of these new number systems, which is the letter I. It also known as the imaginary unit. So, I squared is equal to negative 1. So, square root of negative 1 is equal to I. So, by taking multiples of this imaginary unit, we can create infinitely many more new numbers like 3i, I squared of 5, and negative 12i. So, these combinations are called imaginary numbers. So, ang tawag po dun sa mga binanggit ko po, yung 3i, I squared root of 5, and negative 12i. Ilan lamang po yan sa example na nag-prove sa atin na it is a combinations which is called imaginary numbers. So, however, we can go even farther than that and add real numbers and imaginary numbers. So, hindi lang po dun nagtatapos po pwede po natin gamitan ng operations yung mga imaginary numbers. So, for example, 2 plus 7i and 3 negative square root of 2i. So, these combinations are called complex numbers. So, yun na po yung tinatawag nating complex numbers. Kapag po naggamit na po tayo ng operation na pinagsama po natin yung real numbers at saka ang imaginary numbers. Kung mapapansin nyo po sa pinakita ko sa inyong example kanina, ito po ay nakasulat sa a plus bi, where I is the imaginary unit and the A and B are real numbers. So, ayan po yung aking illustration. Ayan. So, A is called the real part, again, and B is called the imaginary part of the number. So, ayan po sa table below shows examples of complex numbers with the real and imaginary parts if the number is written and the number is written in standard form. So, ayan po. Example ng complex number ay 7i minus 2. Tapos, nakasulat po siya sa standard form which is negative 2 plus 7i. And the real part is negative 2 and the imaginary part is 7. So, ayan. Pansinin nyo na lang po yung iba ko pang binigay na example. So, yan po. Siguro naman po naintindihan nyo na kung ano ang ibig sabihin ng complex number at kung ano po yung real part at saka yung imaginary part. So, sa complex number po, meron po tayong iba't ibang properties. Katulad po ng real number, meron din pong properties si complex number. And let us know what are the properties or what are the different properties that complex numbers have. So, we have theorem 6.1.1 which is the properties of addition of complex numbers. So, let Z, W, and B be complex numbers. Then, the following properties is hold. So, yan. Commutative law for addition. Z plus W is equal to W plus Z. So, additive identity, Z plus 0 is equal to Z. Existence of additive inverse for each Z element, there exists negative Z is equal to 0. In fact, if Z is equal to A plus BI, then negative Z is equal to negative. So, kung meron po tayong identity, commutative, inverse sa addition, meron din po tayong associative law for addition. So, tandaan po na ang pinag-aaralan po natin ay complex numbers. So, z plus w plus v is equal to z plus w plus v. So, we have proof. Now, multiplication of complex numbers is defined the way we would expect, recalling that I squared is equal to negative 1. So, a plus bi times c plus di is equal to ac plus adi plus bci plus I squared BD. I squared po yun. Hindi ko lang po siya na superscript. So, AC minus BD plus AD plus BC times I. So, ayun na po yung proof natin. So, we have example 6.1.1, addition of complex numbers. So, ayan, tingnan nyo na lang po yung example. So, let's have properties of multiplication of complex numbers. So, let z, w, and b be complex numbers. Then, the following properties of multiplication hold. Katulad din nung sa addition of complex numbers, yun din yung properties na meron sa multiplication. So, we have commutative law for multiplication, associative law for multiplication, multiplicative identity, existence of multiplicative inverse for each z is not equal to 0. So, lagi po nating tandaan na z is not equal to 0. So, we also have distributive law. So, we have conjugation of a complex numbers. So, let z is equal to a plus bi be a complex number. Lagi niyo pong tandaan yun ha, na ang complex number, it is written in standard form which is a plus bi. Then, the conjugate of z written is given by a plus bi is equal to a minus bi. So, kung mapapansin nyo po, kabaligtaran po nung ating equation yung conjugate. Pag sinabi po natin conjugate. And then, nakasulat, meron po siyang underline sa taas ng number. Underline. Or sa taas po ng equation. So, geometrically, the action of the conjugate is to reflect a given complex number across the x-axis. Algebraically, it changes the sign on the imaginary part, katulad nga po ng sinasabi ko kanina, of the complex number. Therefore, for a real number a, conjugate of a is equal to a. Example, conjugate of a complex. So, ayan, 3 plus, conjugate of 3 plus 4a is equal to 3 minus 4a. So, ayan po. So, apply na po natin dito yung multiplication property of complex number. So, ayan, conjugate of a plus bi times a plus bi is equal to a minus bi times a plus bi is equal to a squared plus b squared minus ab minus ab times I is equal to a squared plus b squared. So, isi-simplify lang po natin yan. So, next. So, kung may properties po yung multiplication and addition of complex numbers, may properties din po yung conjugate of a complex numbers. So, let z and w be a complex numbers, then the following properties of the conjugate hold. So, ayan po. So, we have division of complex numbers. So, let z is equal to a plus bi and w is equal to c plus di be complex numbers such that c, d are not both 0. So, division of complex numbers is defined as follows. Let z is equal to a plus bi and w is equal to c plus di be complex numbers such that c, d are not both 0. Then the quotient z divided by w is z divided by W is equal to A plus BI divided by C plus DI. So, isi-simplify lang po natin and then nag-come up na po tayo sa ating sagot na AC plus BD divided by C squared plus D squared plus BD minus CD divided by C squared plus D squared times I. In other words, the quotient is obtained by multiplying both top and bottom of then simplifying the expression. So, meron pa po tayo dito yung example, the inverse of A complex numbers. Consider the complex number Z is equal to 2 plus 6I, then Z inverse is defined. Ayan po, let's have a example. 1 over Z is equal to 1 divided by 2 plus 6I is equal to 1 divided by 2 plus 6I times the inverse of 2 plus 6I or the inverse of Z, which is 2 minus 6I. So, ito times lang po natin yan. And then, it is equal to 2 minus 6I, 2 squared plus 6 squared, and then, ito na po yung ating sagot. 1 over 20 minus 3 over 20 is equal to I. Or 1 over 20 minus 3 over 20 times I. So, ayan po yung ating sagot. So, isi-simplify lang po natin. Another important constructions of complex numbers is the absolute value. It is also called the modulus. So, pag sinabi nating modulus, it is a distance. Consider the following definition. The absolute value or modulus of a complex number denoted, ayan po, ganyan po siya isulat, is defined as follows. So, absolute value of A plus BI is equal to square of A squared plus B squared. So, thus, if Z is the complex number, Z is equal to BI and W is equal to C plus DI are two complex numbers, then take a moment to verify this. So, tapos na po tayo sa different properties of complex numbers. So, let's have two forms of complex number. The first one is the polar form. When we say polar forms, it is one of the many ways we can visualize a complex number. They are one way for us to visualize complex numbers on a plane as vectors. So, a complex number in the polar form will contain magnitude and an angle as with the complex number's orientation. So, the form Z is equal to A plus BI is called the rectangular coordinate form of a complex number. So, the horizontal axis is the real axis and the vertical axis is the imaginary axis. We find the real and complex components in terms of r and theta, where r is the length of the vector and theta is the angle made with the real axis. So, ayan, makikita po natin dyan sa ating graph. So, from Pythagorean theorem, which is r squared is equal to a squared plus b squared, by using the basic trigonometric ratios, cosine theta is equal to a over r and sine theta is equal to b over r, multiplying each side by r. So, r cosine theta is equal to a and r sine theta is equal to b. So, the rectangular form of complex numbers is given by z is equal to a plus bi, and then substitute the values of a and b. So, magiging r cosine theta plus r cosine theta times I is equal to r cosine theta plus I sine theta. So, yan po yung form ng yan po yung polar form. In the case of a complex number, r represents the absolute value or modulus, and the angle theta is called the argument of a complex number. So, yun pong r natin is, yan pala po yung ating modulus, and yung theta natin is tinatawag po siyang argument of a complex number. So, in polar form, we have example. Express the complex number in polar form. 5 plus 2i. So, the polar form of a complex number z is equal to a plus bi is z is equal to r times cosine theta plus I sine theta. So, first, find the absolute value of r. So, the absolute value of r is square root of 29. So, yan po yung absolute value. And then, so, ang squared po ng 29 is 5.39. So, yan po yung ating absolute value of r. So, now, let's find the argument theta. Since a less than 0, so use the formula theta is equal to tan raised to negative 1 times b over a. So, 0 is equal to tan raised to negative 1 times b over a. So, theta is equal to tan raised to negative 1 times 2 over 5 is equal to 0.38. So, note that here theta is measured as radians. So, palagi po siyang naka-radians. So, therefore, the polar form of 5 plus 2i is about 5.39 times cosine 0.38 plus I sine 0.38. So, kung kanina is pinag-aralan natin yung polar form or kinuha natin yung polar formula. So, ngayon naman is pag-aaralan naman natin yung Euler's formula. So, Euler's formula or Euler's form, it is named after Leonhard Euler, is a mathematical formula in a complex analysis that establishes the fundamental relationship between the trigonometric functions and the complex exponential function. So, ito po yung ating Euler's formula. A raised to I theta is equal to cosine theta plus I sine theta. So, we have example. So, let's simplify e raised to pi over 2i. So, ang ating formula, the Euler's formula is e raised to I theta is equal to cosine theta plus I sine theta. So, e raised to pi over 2i is equal to cosine times pi over 2 plus I sine pi over 2. So, we have 0 plus I times 1 is equal to I. So, using Euler's formula, it is proved that Euler's identity. It is one of the equations in mathematics which states that e raised to I pi plus 1 is equal to 0. So, ayun lang po and thank you for your time.